Welcome back to DellyMaths Concepts. Here we're solving a GCE 9 marks question. So as you can see here, we have 1 over x plus 1 times 1 over y plus 1 is equal to 1, and xy is equal to negative 2. And we actually want to solve this for x and y. Let us see what's going to happen here. So I'm going to focus, though, on this one at the top there. So I'm going to put in some energy on that one there first. So let us take that and turn each of those. So we are referring to, I want to take each of these and I want to turn them into a single fraction. So for both, I want to turn them into a single fraction, and then we see what's happening from there. So let us take a look. I'm going to turn 1 over x plus 1. I'm going to put 1 over 1 just to turn it into a quick fraction. And then I'm going to do this. So it's going to be 1 times 1, x times 1 over x times 1. So let us set that up. 1 times 1 give me 1. And then 1 times x give me x. And this is going to be over x. So I have that, right? So that is actually representing this. Now, so let me take the other one. So I'm going to take 1 over y plus 1 over 1, and I'm going to do something similar. I'm going to have 1 times 1, y times 1 over y times 1 again. So let's put that together. So 1 times 1 will give me 1, y times 1 will give me y, and this is going to be over y. And then remember, we're multiplying these, okay? So what's going to happen is whenever you multiply, the numerator will multiply by the numerator, the denominator will multiply by the denominator. So at the bottom, I'm seeing xy coming out already. So let's work out the top. So I'm going to FOIL out the top quickly. And when I say FOIL, what I'm referring to at the top, which is the numerator, and I'm referring to these, they're going to be multiplying. So what I have there is actually 1 plus x, and that is going to be multiplied to 1 plus y. So if I should FOIL this out, 1 times 1 will give me 1. 1 times y will give me positive y. X times 1 will give me positive x. X times y will give me xy. So on top, what I really have is 1 plus y plus x plus xy. And all of that is over x times y, which is xy, right? So basically, let me just take this off right here, right? Let's take this off the screen. All right, good. So basically, what I have done is I took this and I reshape it, and it's equal to this, and this is equal to 1, right? So I reshape that and it's equal to 1. But remember, though, that in this instance here, I'm learning that xy is equal to negative 2. So because xy is equal to negative 2, I am now able to substitute negative 2 right here and then see what we could make from it. So let's keep working, right? So we have 1 plus y plus x. Let me write about my x there, plus x. All right, a plus xy, and I'm going to replace this with negative 2. So it's going to actually be plus negative 2. So I could just put negative 2 right here, right? So it's going to end up being a negative 2 right there. All of this is over xy, which is actually negative 2. So I'm going to put negative 2 right here as well, right there. Remember that this is equal to 1. Now, basically what I'm going to do is I'm going to turn this, get rid of the fraction. So I'm going to multiply the left side by negative 2, right? Right here, multiply by negative 2. And I'm going to multiply the right side by negative 2. So if we simplify negative 2 into itself one time, so on my left-hand side, let's say I put the x in front, so I have x plus y, and then this positive 1 and this negative 2 will actually give me a negative 1. This is equal to negative 2. So I just kind of clear that up, right? Now, at the same time, if I add 1 to both sides, what I'm really left with, as you could see right about now, what I'm really left with is this. So we're definitely left with x plus y is now equal to -1. So that's what I do have now, right? So what I'm going to do is I'm going to now represent this in a more simpler way that we can accept. For example, so this is my first equation at the top. So it actually came down to this. So we're talking about having x plus y is equal to -1. So we have found that out. And then this was actually there. So xy is equal to -2. So what we're going to do now is that we could now we could write x in terms of y using this. So let us say I call this my first and then call this my second. I could use the first one to create a third equation, and it could be like this. Y is equal to -1, subtract x from both sides here. If I do that, as you could see, it's going to be minus x there. So, so I use equation 1 to create equation 3. Now I'm going to substitute. This is what I'm going to do. It's my intention to substitute. I do want to substitute -1 minus x, and I'm going to substitute that for y, okay? And I could do it in equation 2. So let me write equation 2 now. What is equation 2? Equation 2 says that y is equal to -2. So remember though, for y, I'm going to put, so here it is, for y, which is this, I'm going to put -1 minus x. Let's do that. So I have x times y, and it's -1 minus x, and this is equal to -2, right? So continuing this, I'm going to distribute my x throughout. So what I'm going to actually have there is x times -1, and that's going to give me -x. X times -x will give me -x to the second power, and this is equal to -2. Now, because I'm seeing that I have a quadratic here, I'm going to migrate the -x and the -x squared to the other side. And mathematically, it means I'm going to be adding x to the left side. I'm going to be adding x squared to the left side. So bottom line, I'm going to have x squared being added to this side and x being added to this side. So let's rewrite what we have. So basically what we really have is x squared, which is this, plus x, which is this, minus 2, and everything is actually equal to 0 right now, right? Sorry about that. And this is equal to 0. So what I'm going to do is to try to solve this now. So in solving this, I could factorize, right? And we could do this quickly because my a value is 1. So I could set up, there's a x here, there's a x here, there is a 2 here, and there's a 1 here. But because I definitely need a positive middle term there. So the 2, which is the larger one, will be positive, which means this will be negative. So we just factorize that. So x plus 2 into x minus 1 is working well for us. At this moment, we could say then x plus 2 is equal to 0, which means if I subtract 2 from both sides, then x is equal to -2. Or x minus 1 is equal to 0. And if I add 1 to both sides, then x is equal to 1. So we actually have our two values for x. As you can see, x is equal to, so I'm just going to mark them off. X is equal to -2. X is equal to 1. All right, now, because we do know this, we could go back to my third equation here, and it says here. So here's the deal. So I want to know when when x is equal to -2, right? Let's write this down. When x is equal to -2, I want to know what is y, right? So that's just going to be one of the cases. And the second case is going to be when I want to know when x is equal to +1. So I want to know what's going to happen there. So let's put it. Remember, though, that right here in our third equation, we got y is equal to -1 minus x. And I'm going to put -2 where the x is. So let us see what we have. So this is going to equal to -1 minus. And then for the x, I'm going to have to put -2. So here it is. We have a -1. These two minus signs are going to clash. So it's going to be a +2 coming out, which means that y is equal to 1. What is this suggesting? It's suggesting that when x is equal to -2, y is equal to +1, okay? And so we have that. Now let's take a look at the other case. So when x is equal to 1, remember that y is still equal to -1 minus x. We're still going to be substituting 1 wherever x is now, so -1 minus, and then in bracket we have 1. So here is the deal. Y is going to equal to, this is going to give me -1, -1. So this is -2. So the conclusion is when x is equal to 1, y is equal to -2. So these are the two solutions that we came up with to solve that problem there. And that's a lot of work. But guess what? See you next time on DellyMaths Concepts when we look at more problems like these.